Hello dear participants, myself Dr. Wankhade, Assistant Professor, Department of Chemistry, Shri Shivaji Science College, Amravati. Welcomes you all on online value-based course on Chemical Handling and Laboratory Safety, CHLS 2022-23. Today we are going to discuss on the solution preparation. What is the very first question is, what is the solution? Actually, solution is the homogeneous mixture of two or more substances in a variable composition. So, to prepare the solution, we require at least two or more than two components to form the solution. But although we can prepare the solution by two or more components, but there are two main components of the solution. One is the solvent and another is the solute. So, what is the solvent and what is the solute? Solvent is that component of the solution in which the solute is get dissolved, and you can also define the solvent as it is the component of the solution which is taken in a large amount. And what is the solute? Solute is that component of the solution which is get dissolved into a solution, or you can also say that solute is the component of the solution which is taken in a small amount. So to prepare the solution, we require the solvent and the solute. The solvent is only one substance, but you can add two or more solutes into the same solvent to prepare a solution. For example, sugar syrup is the solution which is prepared by dissolving the sugar into a water, where water is your solvent and the sugar is your solute. You can have taken the example of lemon, which is prepared by dissolving the lemon juice, salt and the sugar into the water. So in this solution, this is also homogeneous mixture. Here your lemon juice, your sugar and the salt, these three are the solute, whereas water is the solvent. So that's why solution can be prepared by the homogeneous mixture of two or more substances, where solvent is one component and you can dissolve one, two or more than two types of the different solutes into the solvent to prepare a solution of variable composition. Now, how we can measure the composition of the solution, or how we can express the composition of the solution? So, the solutions are expressed in terms of the concentration. So, question arises, what is the concentration? Concentration is the amount of solute dissolved in a given amount of the solvent. So, on the basis of the concentration, the solutions are expressed in a various way, that is in percentage solution. So, in percentage there is percent by mass and percent by volume. The molarity is there, molality, normality and the parts per million. So, these are the different way by means of which we can express the concentration, because the amount of substance or the solute dissolved in a solvent is variable. That's why the concentration of solution is also variable, and this concentration is expressed by means of percent solution, molarity, molality, normality and parts per million, which is also called as the ppm. So let's first discuss what is the percent solution. So what is the percent solution? It is given in what is the amount of the solute dissolved in a 100 gram or 100 liters of the solution. So this percent solution is further classified into percent weight by weight, percent weight by volume and percent volume by volume. So percent weight by weight is denoted by the W by W, percent weight by volume is denoted by the W by V, percent volume by volume is denoted by V by V. So let's first have the what is the percent weight by weight. So the percent weight by weight can be defined as it is the mass of solute in grams per 100 gram of resulting solution. Means if we have the 100 gram of resulting solution, in which how much amount of the solute in a gram is dissolved, that will give you the percent weight by weight solution. So the formula for the percent weight by weight is given by mass of solute upon the mass of solution into the 100. So the percent weight by weight is given by the mass of solute in gram in 100 gram of solution. Second one is the percent weight by volume solution. So what is the weight by volume? So it can be defined as the mass of solute in a gram per 100 ml of resulting solution. So this is denoted by the percent W by V and given by the formula is equal to mass of solute in gram upon the volume of solution is in ml into 100. So this is the percent weight by volume. Third, the percent volume by volume, which is given by V by V solution, can be defined as the volume of solute in ml dissolved in per 100 ml of resulting solution. So the formula of percent volume by volume is given by volume of solute upon the volume of solution into the 100. So in percent volume by volume, both the solute and solvent is in a liquid form. In percent weight by volume, the solute is in solid and the solvent is in liquid. But in percent weight by weight, the variable that may be the solid or might be a liquid. Next concentration term is the molarity. So what is the molarity? Molarity is the number of moles of the solute dissolved in per liter of the solution. So what is the number of moles? How can we define the number of moles? Number of moles can be calculated by the weight of solution upon the molecular weight of the solution. Means whatever the given weight we are taking for the preparation of the solution upon the molecular weight of that solute will give you the number of mole, and number of mole is denoted by the small n. So see, small n is given by W2 upon M2. So the formula of molarity is given by the number of moles of solute upon the volume of solution in liter, and molarity is denoted by the capital M. So number of mole is given by the small n and the volume of solution by the V. So as I already told you that number of mole is given by the weight of solute divided by the molecular weight of the solute, and the volume is taken into the liter, but if we take the volume in ml, so we need to multiply the whole entity by the 1000. So this is the resulting formula of the molarity, that is W2 into 1000 upon M2 into volume in ml. The unit of molarity is given as the mole per liter, but it is oftenly called as the molar solution, which is denoted by the capital M. So the molarity can be have a different way, that is the millimolar solution, macromolar solution, nanomolar, picomolar and femtomolar. So what is the millimolar? It is a 10 to the power minus 3 molar. Micromolar is 10 to the power minus 6 molar. Nanomolar is 10 to the power minus 9 molar. Picomolar is 10 to the power minus 12 molar, and femtomolar is 10 to the power minus 15 molar. So these are the some different kind of the molar solution which are represented over here. Next concentration term is the molality. Now what is the molality? Molality is again a number of moles of the solute dissolved in per 1000 gram or 1 kg of the solvent. Now see, what is the difference between a molarity and molality? In molarity we have taken the solvent in a volume, whereas in a molality we have taken the solvent either in a gram or a kg. So what is molality? It is the number of moles of the solute dissolved in per 1000 gram or 1 kg of the solvent. Molarity is denoted by the small m, and the formula is number of mole of the solute upon the mass of solvent in kg. So again number of mole is denoted by the n and the mass of solvent by the W1. We know that number of mole is given by weight of solute upon the molecular weight of solute. So n is replaced by W2 upon M2, and weight of solvent is given in W1 in the kg. If we convert this kg to the gram, we need to multiply this whole entity by the 1000. So our resulting formula is W2 into 1000 into M2 into W1, where W2 is the weight of the solvent taken, M2 is the molecular weight of the W2 is the weight of the solute taken, M2 is the molecular weight of the solute, whereas W1 is the weight of the solvent taken for the preparation of the solution. Now about the unit of molality, the unit of the molar concentration are mole per kg, but it is oftenly called as the molar solution and denoted by the small m. Next concentration term is the normality. Now what is the normality? It is the number of grams equivalent of solute dissolved in per liter of solution. Now what is the gram equivalent? The gram equivalent weight is calculated by dividing the molecular weight of solute by its replaceable valencies. So normality can be given by the number of gram equivalent of the solute dissolved in per liter of the solution, and it is denoted by a capital N and given by the formula number of gram equivalent of the solute upon volume of solvent in liter. But if we want to convert this liter into the volume of solvent in a ml, then multiply this whole entity by the 1000. Now again about the unit of normality. The unit for normal concentration are gram equivalent per liter, but again it is oftenly denoted by the capital N and pronounced as the normal solution. The last concentration term is parts per million. So what is the parts per million? It is expressed as a gram of solute per million gram of the solution. Means here we are taking the solution in per million gram, where we are dissolving the certain amount of the solute in a gram, or you can also call it the gram of solute per million ml of solution, and the it is also pronounced as the ppm, parts per million, and the concentration is ppm is given by amount of solute upon amount of whole solution into 10 to the power 6. So this 10 to the power 6 is your million, that's why we multiplied it by the 10 to the power 6. So this is all about the how to measure the concentration of the solution and the component of the solution, and also discuss about the definition of the solution. Now next we have the most important part, now how to prepare the solution, because when we are performing the various experiments in a laboratory, we need the solutions of the different concentration and we have to prepare that solution into laboratory. Some of the solution can remain with the same concentration after the preparation of many hours, but there are some solutions whose concentration is get changed. That's why we needed to prepare that solution at the time of the experiment. So it is necessary to learn how to prepare solution in a proper way. So very first thing in a preparation of the solution, what we have to do, we have to weigh a specific amount of the mass of the solute on either by using the weighing bottle or using the clock plate. So see, this is the electronic balance on which we are measuring the weight of the solute with the help of either weighing bottle. You can use the weighing bottle or you can use the clock plate. So glass, we can also use the watch glass also. With the help of that we can measure the amount of the solute. Once we measure the desired amount of the solute, so how much solute we require, for example, if we have to prepare the one normal solution of the NaOH. So what is the normality? It is a gram equivalent weight of solute in a liter of the solvent or 1 liter of the resulting solution. So what is the equivalent weight of the NaOH? Equivalent weight is given by molecular weight upon divided by its valency. So NaOH having a replaceable valency is only 1. So its valency is 1 and the molecular weight of NaOH is 40. So 40 divided by 1 is the 40, means the equivalent weight and the molecular weight is same for the NaOH. But in case of the H2SO4, it is variable. For H2SO4 it is 98 is the molecular weight of the H2SO4, and it have the 2 replaceable valency, means 2H plus that can be replaced. That's why the equivalent weight of H2SO4 is molecular weight divided by 2. So molecular weight is 98 divided by 2. So it is a 49. So for H2SO4 the molecular weight is 98, whereas the equivalent weight is 49. So to prepare for example one normal solution, we have to take the 40 gram of the NaOH in 1 liter of the solution. But if you reduce the amount of solvent, means if you have to prepare the solution in 100 ml, so you have to also, so 1000 divided by 10 is 100, then again 40 divided by 10 is 4. So So you need to dissolve 4 gram of the NaOH in a 100 ml of the distilled water. So in this way, whatever will be the weight we have calculated with the help of the formula. So that is measured with the help of either weighing bottle or your watch glass or the clock plate, and then transfer that amount of the solute into a beaker which contain a little amount of the water. But before transferring the solute into the beaker, it is necessary to first wash your beaker properly and rinse it with the deionized water. After that, transfer the solute transfer the solute into a beaker, and if certain particles are attached to the your weighing bottle or to your clock plate, wash that particles with the help of the distilled water and transfer whole amount of solute into the beaker and add little amount of the water and dissolve that solute into the water. When the solute is completely dissolved into the little amount of the water, transfer that solution from the beaker into a volumetric flask with the help of the funnel, and then the remaining volume is filled with the deionized water. So you need to add the distilled water, deionized water into the volumetric flask, and the last up to the given mark, and at the end the very if you needed a very small amount of the water to go up to the given mark, the last droplets of the water add with the help of the dropper and maintain the level into the volumetric flask. Now keep in mind that we are preparing some colorless solution and some color solution. At that time, it is needed to know which hibiscus level should be taken. But when you add the last drop of the water into the volumetric flask, then just put the stopper on it and just shake that bottle for the 20 times so that the solute in a solvent is homogeneously distributed into whole solution. Now see, as I told you that we are preparing the two different type of the solution. One is your colored solution and another is your colorless solution. So when you are preparing the color solution, so in a color solution it is difficult to observe the lower hibiscus. So that's why in such a solution we need to see the upper hibiscus in a colored solution. So suppose this is the mark given on a volumetric flask. So you have to add the water, deionized water or the solvent up to that limit when you can see the upper part of this solution, that upper hibiscus touches to this line. Whereas for the colorless solution we have to consider the lower hibiscus, means we need to add the solvent in that amount. The lower hibiscus of the solution is touches to the given level. So this is all about the solution preparation. Thank you.